Great. So we are talking about collections, right? And we started talking about lists, correct? So we are talking about list. Now, list, as I said, it's a linear, mutable, linear, mutable, ordered collection, right? So we have seen how to use list as um, uh, how to declare list, correct? So we declare list using square bracket, and we started talking about, I think, two uh, methods also, right? But we'll start from again. So let's say you have a list, okay, and list has values like 10, 50, 30, 20, 90, right? And let's say we'll add one. Okay, let's not add it here. So this is your list, right? Now, as I said, to access methods of list, you will have L1 dot, right? And L1 dot, and you get the entire list of methods that you can use here. So we'll talk about first how to add and remove members. Okay. So unlike string, okay, here when you perform these methods, the list will be impacted. Original list will get changed, will get impacted. Okay. In the string, what we saw was, okay, when you perform these methods, since strings are immutable, the original variable is not impacted. It will return you a new variable, new string variable, right? But here we don't have to, store as a new variable. So if I say L1 dot, okay, and let's say I put append, okay. So what append does, append will add the members. I'm going to pass the member here. Okay, so let's say I put 25. So append will add at the end. Automatically it gets added at the end. So if you talk about, let's say, queue, right? When you stand in a queue for movie ticket or cricket ticket or anything, okay, you start getting, you add yourself in the queue, right? When you come, you add yourself at the last of the queue, right? That's what append does. When you add a member to this, okay, list, it gets added at the end. So if I now print L1, if I now print, okay, L1 after, let's say, append, okay, and I say L1, okay, so let's run this and see. So 25 got added at the end. Now if I say, okay, 25, 35, 45, right? So first 25 gets added, and after that 45 gets added. Okay, so it gets added at the end. So append will always add a member to the list at the end of the list. Okay. Now you have something called as insert. Okay, insert takes position and the value to add. So if I say L1 dot insert, you see here self, I told you to ignore value. So first variable you have to pass is the value, then not index, sorry, insert. Okay, second one. So you have index actually. Okay, so index is the first, I mean, this is the first variable that we need to pass, and which is position. And object is the value that you need to add, right? So it takes position and the value. So first you have to give position, right? Which is index here. So let's say I give index as 2 and variable as, let's say, 35. So this is your list, correct? So 0, 1, okay, will not be impacted because I'm saying add at the second position. So 0 and 1 is not impacted. Your 35 will get added at the second, right? Index 2 means third position, right? It gets added at the index 2. And everything else will shift by a space. So now if I say L1 after, let's say, insert, and when you run it, you see, since I said 2, it got added at the second position, 2 comma 35. Okay, it gets added. Let's say I run again 2 comma 65. Okay, what happens first at index 2, 35 is added, and next at index 2 again 65 is added. So 35 will now move to the right and 65 will come here, right? So first 35 gets added and then 65 got added. Right? So this is how you can use insert to add a specific position. Okay? If you are using um, append, it will always add at the end of the list. Okay? So similarly, you have two other methods to remove. I think we saw that in the last session, but let's repeat it anyways. So L1 dot, okay, you have remove and you have pop. Okay, so remove and pop are the methods to remove or delete element from the list. So remove takes value and your pop takes index. So pop takes position and your remove takes the value that you want to remove. Okay, so if I say remove, okay, so remove takes value to delete, right? So remove, let's say 35. So I'll say remove 35, right? I can say L1 dot remove 90. It will remove 90. And now when I say print L1 after remove, okay? So this was your L1 before we started with remove. Now we said remove 35, so 35 is gone first. Then we say 90, 90 is gone first. So if you see, compare this to list, you'll see 35 and 90 gone from the list, right? So in this case, if I remove something which is not there in the list, okay, let's say I try to remove 900 and 900 is not in the list. So if I run it, okay, so you get error. So first you have to check if the value that you want to remove is in the list or not. Okay, first you have to check if the value is in the list or not. If it is there, only then you remove it. So how do you check the value in the list? So you have count. Okay, so I say L1 dot count, count value. Now if I say count 90, this is going to return number of 90 in the L1. And of course, this has to be more than 0, right? Number of 90s, okay? This has to be more than, okay? This has to be more than 0, then only can remove it, okay? So after removing 90, now you see count is 0, right? Now you might have two 90s. Let's say I put one more 90 here. Then which 90 will remove? The first occurring 90 will be removed. So see when I, okay, so we have 90 here and 90, this 90 is gone, but this 90 remains, correct? So now if you number of 90s, you get 1. Okay, so number of 90s you have is 1. Okay, because we had 2, we removed 1. So now it, you get 1. So this is how you have to do. So before you remove, first you have to make sure that value is there. Otherwise, your program will have error and your program will, this is called as runtime error. We'll have a separate discussion about errors. This is called as runtime errors. Okay. So at runtime, you get the error. You don't get error in the beginning. When you run the program, you get this error. Make sense? Okay. So yeah, so this is your remove. Now you have pop, correct? We discussed about pop. So what pop will do? Pop will take the position. Okay. Pop will say delete from a specific position. So if I say L1 dot pop, okay, you provide the index. Index at which you want to delete, right? So I want to delete element add. Okay, so this is your list after remove and remove 65. So to remove 65, what should I say? To remove 65, I should say index 2,
2.
right? Yes, I should say index 2 because 65 is at second position, right? So I
Correct.
should, yeah. So I should say remove 2, right? And now if I say L1 after, let's say, pop, okay? And when you run it, 65, is it gone?
Yeah.
Yes, it is gone, right? So this is how you can, you know, uh, work with the position. Now, again, you have to be careful because if I give a position which is beyond the length of the list, it will give error, right? If I say positions 20 and we don't have 20 elements, right? Or 21 elements rather, right? It says index out of range. Index out of range. Guys, can you go on mute? Okay. There's an echo coming from your side. Okay. So if you're on speaker, please go on mute. Okay. So what happens here? Okay, we are giving index which is not there at all, right? So when you, okay, if you use things like that, it will obviously give you index out of range error. Okay. Now, what do we do in this case? So before you perform remove, you need to check if that index is there or not. So how do you do that? Len. Okay. So len will tell you how many elements are there. So if elements are 20, then you have index up to 19 only. Okay. If the number of elements are 20, you can't delete element at 20th index. Okay. So the index at which you want to delete has to be, okay, has to be more than, right? Has to be the number of element has to be more than the index at which you want to delete. Makes sense, correct? So okay, you can, okay, check before you doing pop. If you don't check, you will end up having error, runtime error. Okay, so this is about, okay, how to add members to the list, how to remove members from the list. Okay. And we also discuss count, right? Count will tell you how many elements are there. Now, you have, let me remove this, okay? We'll move them to, okay. Now let's look at L1 dot, okay. So we have done all these things. Okay, let's look at copy. Okay, so now let's say this is your L1. Okay, this is your L1 and I want to create a copy of L1. I want to create another list which is copy of L1, right? So there are two ways to do it. One, you say L2 equal to L1 dot copy, okay? And second is I can say L3 equal to L1, okay? So there are two ways to create a copy of a list. Using copy method or directly you say equal to. Now if I print, okay, if I print something like this, I give L1 equal to, it is your L1, right? And we'll print L2, we'll print L3, L2, L3. Okay. So what do you notice here, output? Do you notice anything unusual? No, right?
Nope.
No, right? We created a copy, so it is creating a copy, right? So your L1 is original value, and your L2 and L3 have exact same values as L1. Okay. Now let's say what I'll do is, okay, I will add some values to L1. Okay, L1 dot append. Okay, say 11, and I will add to L2, L3, and L2 and L3 also. Okay, so I'm adding L1 dot append, L2 dot append, and L3 dot append. Okay, let me add different 11, 22, let's say 33. Now let me print again. Okay, so I'll call this as 2 so that we are able to differentiate between previous values and next value. So this is 2 is after performing append to L1, L2, L3. Now you tell me, do you notice anything unusual? What you don't understand here?
Well, in the first L1 itself, 33 is printing. That is something strange, right?
First is 1133 and because L2 equal to L2, that's why 22.
I can't hear you properly, Roshni.
Yes, sir.
Yeah,
I
can
mean,
you repeat it?
first is L1 is equal to L1. That's why 11 and 33.
Your lift sound is coming better than your sound, Roshni. Okay, so maybe yeah, what you're trying to say, see here, there is a difference. Okay, you will notice the difference is if L1 and okay L3, they behave as if same. So when I add 11 to L1, 11 got added to L1.
Sir, L1 is equal
Okay,
to
I'm repeating. Okay, so no worries. You can go on mute. So when I add 11 to L1, okay, when I add 11 to L1, 11 got added to L1, right? But it also got added to L3. And when I add 33 to L3, 33 got added to L3, but it also got added to L1. Okay, so difference is, okay, when you create a copy, this is called as shallow copy. It's like photocopy. So now let's say if I give you a paper and I'll tell you, okay, do a copy, right? So you create a copy of that paper. So the moment you take copy, the moment you create copy, they'll have same values. But after that, there are two different copies, isn't it? So after you take a copy, if I add something in my paper, if I write something on the paper, will it be reflected in your photocopy? No, correct? Because at the time of photocopying, it copies exactly the same stuff. But once the photocopy is done, then they are two different things. There is no connection between those two papers. If I add something to the paper or you add to something to the paper, that will be specific to my paper and your paper. So if you add something to the list, okay, it is specific to my list and your list. But when you say equal to, we call it as deep copy. Okay. Okay. So this is like giving, okay, two lists with same name. Or rather than not, this is not right. It's like same list with two names. Though the names are different, but they refer to same person. It's like we all have, right? Pet name and certificate name, right? Now, whether I call you by your pet name or the certificate name, you will only respond. So L1 and L3 is like certificate name and pet name. Okay? Because they are pointing to the same list, just that their names are different. So if I say L1 dot add or I say L3 dot add, it means same. Did you understand? So this is the difference between equal to and dot copy. If your intention is to create a copy and then make it separate, you should use copy. And if you don't understand, then you'll end up into problems, right? Your output will not be as you expect. So if your intention is that, okay, like so till this point, step is same. From next point onwards, you have to perform two different set of activities. Then you say, okay, take a copy. You go and do whatever you want to do. I will do whatever I want to do, right? So it is fine. You take a copy, and both have both are important. You just need to know which one to use where. Based on your requirement, you have to pick one of these, isn't it? So you're saying, okay, at this point, okay, take a copy and then you do whatever you want to do. I'll do whatever I want to do. But when you say equal to, it's like saying same. Okay, it's same. Okay, whether you add to the first one or you add to the second one, okay, there will be one single copy, and one single copy is affected. All right.
Question. So irrespective of how many ever assignment it's done, the reference will be the same, is it?
Yes.
For example, I assigned L4 is equal to L3.
Mm-hmm.
Then again L1.
Yeah, you're giving third name.
Third name. Oh, okay.
Yeah,
Okay.
some of you might have
Names for the same.
two nicknames.
Got it. Okay.
Right. So equal to is like giving another name to the same list.
Same main list. Okay, sounds good.
Right.
Thank you.
Okay. So this is how we use copy and equal to. Okay. So next one. Okay. It's L1 dot. Let's see what we have. Okay. I want to do clear at the end. Okay. Index. Index will tell you, okay, this is exactly the same, like I think we had index in the string also. It will tell you the index of the value, okay, and it will tell you index of the first occurrence. Okay, so let's say this is the value, right? If I say index of 90, let's say, okay, so I can say print index of 90. Now index of 90 means, okay, what is the index value of this? So this is your 0, 1, and 2, right? So that's why you get 2 here. First found value, right? It always look at the first value. So you have two 90s, okay, but it will give you the index of the first occurring value. Now, index can take start and end value also. So I can say, okay, tell me if there is any 90, okay, not if there is any 90, sorry, that is count. If there is any 90 or not, that will be told by count. Okay, when you are performing index, okay, so you assume that it is already there, correct? It may not be there, but you assume that it is there, and then you're finding the position, right? Now, what happens if the value is not there? Let's say I put 900 again in this case. Okay, so you see, you get a value error, right? So that's why you have to be careful. Okay, if you want to find if 90 is there or not, so you have to check with count. Index assumes that value is there and you want to find the index of the value. Okay, so when you are doing remove value, remove, or you're doing index, first you make sure that value exists. Okay, write if count more than 0, then you perform these actions, otherwise else you say value is not in the list. Okay, so okay, 90. Now I want to check if, okay, so let's say I want to ignore 2, right? So I'll give 3 here. From 3 to, now this is your 3. 3, 4, 5, 6. So I want from 3 to 7. Between 3 and 7, is there 90? So yes, it has index 4, right? 0, 1, 2, 3, 4. So since we started from 3, it is not going to check for 0, 1, 2. It is going to check from 3 up to 7, right? So it says, yes, I found 90 at index 4. Okay, so you can even use start and end to give a specific location. I want to check within first 5 values. List can have multiple values, but do you have particular value within the first 5 values? Then again you will use 0, 5 to make sure that value is within first 5 values. Okay, so that's how your index works. Then you have extend. Extend is to to add a list to another list. So extend is like saying L1 equal to L1 plus L2. Okay, so it is same as extend is same as extend is same as saying L1 equal to L1 plus L2. So if I declare L2 equal to 1, 2, 3, and then I say L1 dot extend L2. Okay, so now if you print L1 after extend, you get 1, 2, 3 got added, right? Same way. So first you have L1 and then at the end L2 got added. So this is what extend is. Okay, then you have sort. L1 dot sort. This will sort the value. Okay, so now if I run L1, L1 after sort, so you see 1, 2, 3. So it got sorted in increasing order. Sort in ascending, we say, right? Ascending order, increasing order. Now here, if I go and say L1 dot sort, and here I say reverse equal to true. That means sort in reverse order. Sort in descending order. So you can say print L1 after reverse sort, let's say. So you can, you can directly sort the elements. Okay. So now you see it does in reverse order 90, 90, 50, so on. Make sense? Okay. Now, so this is about, you also have something called as um, L1 dot reverse. Reverse will reverse the elements anyway. So let's say we'll do this before doing the sorting. So L1 after extend, right? Here I do L1 dot reverse. So now if you say, if you print L1 after reverse, so what happens? The element simply got reversed. So it's not sorting. You just want to reverse the element, right? So it's 10 to 3. It became 3 to 10. 3 to 1 reverse order. 3 to 1 33 11 90 20 90 50 10. All right. So you got elements got reversed here. And finally, last one is L1 dot clear. Clear will not delete L1 but removes all the elements from list. So if I say L1 after clear, so you say L1 and when you run it, you get empty list. So L1 variable is there, but it has no value. All the values, whether it is 1 or million, all the values will be removed and you get blank list. Okay, so this is how your list works. Okay, we have covered almost everything now, right? So these are methods of the list, and list is one of the most widely used collections. Okay. So yeah, just practice. And I think in the assignment, I have even given you questions from the list. Try to do that. Any questions?
So, actually, I have a different set of question outside of this. So basically, I'm having some problem. Like the idea was to not use any inbuilt functions while trying to solve it, like so that we develop the programming construct ourselves. Like,
No, no, sorry.
so-
Your what was the last part? You want what?
I mean, like, if we have functions like list function, like L1 dot sort, L1 dot reverse.
Mm-hmm.
So, or the slicing reverse is
Mhm.
reverse using slicing.
Mhm.
So that way, like, we don't have to do that basically. So can I tell you the question like what I have to do?
Mhm.
So given the problem statement is okay, I'll just check if I can paste it in the message.
Yeah.